Okay, let's go now for part B here, right? We have to calculate this integral and prove that this integral is equal to pi. All right, how are we going to do this? Well, first of all, what I'm going to do is a change of variable, and the reason for that is the following. Take this function here, right? And actually, well, what you have is an interval AB, can be positive, negative, doesn't matter, right? I'm drawing it in the positive side, but it could be anywhere in the real axis. What I have here in the denominator is a parabola. Okay, you don't really have a parabola because this is to the power minus 1/2. So actually, you have a function that diverges, right, at A and at B, but it does so let me just plot it like this. It does so like this, okay, symmetrically. That's my point here. That's what I want to stress here. So whatever the argument is, it is symmetric with respect to this axis because the parabola here, that is what you have in the denominator, is symmetric. Okay, so let's try to express the same parabola with respect to the midpoint, which is this one here. Okay, let's try to express it like that. So if we do that, so we change the variable here, well, we introduce a new variable like this. So our x is going to be the midpoint plus a new variable, but we're going to use a parameter c in order to find which value of c is more appropriate to scale the x. Okay, I mean, we're going to try the best c that we can make use of. Let's see if this simplifies the argument. To begin with, what is x minus x minus a? X minus a. Well, if you subtract a from here, what you have is b minus a over 2 plus ct. All right. What is b minus x? Well, if you subtract this from b, you have b minus this, so you have b minus a divided by 2 minus ct. Okay, if you see these two expressions, we can conclude that a nice and appropriate choice for c would be b minus a divided by 2, because if we do this, we have exactly the same factor here and here, and we can take it out as a common factor. 1 minus t, and 1 plus t, sorry, and here we have b minus a over 2, 1 minus t. Okay, so this is the factor that we're going to use for c, right? So our change of variable is actually this one, x plus b over 2 plus a minus b over 2, b minus a over 2 times t. Okay, so dx is going to be b minus a over 2 dt. And now the important thing is the square root of x minus a times b minus x is, well, you have this twice, so you multiply this by this, you have a square. Since we are taking its square root, you have b minus a divided by 2. And then you multiply this by this, and you have 1 minus t squared, and you have the square root, of course. So you transform this expression into something easier to handle. Okay, now you see you have this factor from the differential here, you have this factor in the denominator because of the root, they cancel each other. Okay, so what we have is that this integral is equal to the integral. We'll see now what the limits are, but here what you have is just dt over the square root of 1 minus t squared. Okay, what happens with the limit now? Okay, we have to just substitute x by a and b and see what happens. So if we have here a, for x equal to a, well, actually you can see it here more easily. If you make x equal to a here, you have 0 here. And in order to get 0 here, you have to take t equal to minus 1. So the lower limit is equal to minus 1. The upper limit b, if you make x equal to b, then this is 0. And for this to be 0, t must be 1. So what you have here is 1 as an upper limit. So our integral, this integral here, is equal to just this. Every value of the constants have disappeared, which means that this integral here, despite the appearance, does not depend on a and b. It's a constant, right? So it makes sense that this is equal to pi. We still don't know which constant is that, but it makes sense that it's a constant independent on a and b because that's exactly what we have obtained, right? Okay, so what is the integral of this? Well, this is very easy because this is the derivative of the arcsine. So the arcsine is a primitive of 1 over the square root of 1 minus t squared, so we just have this. What is the arcsine of 1? Is pi half. And what is the arcsine of minus 1? Is minus pi half, since we are subtracting, this is pi. So that's the answer to this question.